So in this session we are going to discuss about AP, HP and GP. Actually, AP is a reciprocal of HP. If you learn the AP, the HP is not necessary to learn because it is a reciprocal. If your the AP value is 5, HP value is 1 by 5. It's a little bit easy. So let us explain first what is the AP and what is the HP and what is the GP. Before taking this concept, I will explain what is a sequence and what is a series, and what is a finite number and what is a infinite numbers. Okay, and what is a sequence? A sequence is nothing but it is when you are writing the numbers, there is a exact pattern. There is a pattern to write. When you are presenting any numbers, there is a pattern. So, for example, 2, 4, 6, 8, etc. So there is a pattern here because it's a multiple of 2. It's a multiple of 2. Otherwise, it's a set of even numbers. So there is a pattern. So let me write. There is a 100 and 90 and 80 and 70, etc. Again, there is a pattern here because it's a 100 minus 10, 90, 90 minus 10, 80, 80 minus 10, 70, etc. Like that. So let me take one more number. One more number is a 1 and 4 and 9, 16, 25. Yes. Will you answer this one? Is it any pattern? Yes. There is particular reasons are there. Here there is a perfect square numbers because 1 square is 1, 2 square is 4, 3 square is 9 and 4 square is 16 and 5 square is 25, etc. So 36, 49 and 64, 81, 100, 121, etc. Is that correct? So those are the numbers. There is a pattern, exact sequence. This is not a sequence. And the sum of a sequence, it is nothing but series. The sum of a sequence is nothing but what? Series. Here also, the sum of a sequence, it is nothing but series. Here also, just if you are adding those elements, we will get a series. Okay, there is a sequence and series. Next, what is a finite and infinite number? What is a finite and infinite? So finite is nothing but it's a countable. It is countable. So for example, you can easily count your family members. Is that correct? Yes, that is a finite number of members. Infinite. Is it possible to count the stars? No. It is the best example for the infinite. In this case 2, 4, 6, 6, etc. So there is etc. is nothing but, so there are infinite numbers. We can't count the numbers here. So etc. is nothing but so many numbers are there still. And even the first number is 0, 1, 2, 3, 4, etc. 100, 1000, 1 lakh, 1 crore, etc. We can't find the last number. So last number we have to say it is infinity. We can't define it, not define it. So this types of number, it is known as infinite. Ins, if 2, 4, 6, 8 and let me take the last number is 100. Is it countable? Yes, because in a between few elements are there. But 2, 4, 6, 8, etc. it is countable numbers. It's an example for finite. And this one, it is a finite. It is finite. And this one, this is a infinite. Correct? Infinite. And if you are taking like this, there is a 100. Is it a countable? Yes, it is a countable, hence it is a finite. Okay? There is a finite and infinite. Okay? So you just write down the definitions. If you want to know the complete details about the sequence series, you just read the descriptions. Read the description, we will get to know all the concepts. Okay? And next we will move on to the AP. AP is nothing but arithmetic progression. GP is nothing but geometric progression. HP is nothing but harmonic progression. So first let us take AP. Okay. So let us take the arithmetic progression and harmonic progression. If you learn the arithmetic progression, it is not necessary to learn the harmonic progression. If they are given any type of questions in a harmonic progression, you just take a what? Arithmetic progression, find the answers and reciprocal it will get the answers. I will explain the briefly. Before taking harmonic progression, so let us take arithmetic progression. So what is the arithmetic progression? What is the nth term of an arithmetic progression? What is the general formula? And what is the nth value? That means the sum of n value. I'll explain briefly. You just follow the what? Listen it carefully. The first is arithmetic progression. Arithmetic progression is nothing but, so we are adding a fixed number to the sequence, to the previous number. We will get a proceeding number. That means here there is a 2, 4, 6, 8, 10 and etc. When you are writing the any numbers, the common difference of these two numbers should be the same. That if there is a difference is 2, difference is nothing but when you are adding the first number with the fixed number. Fixed number is nothing but that is what common difference 2. If you are adding the 2 to the 2 will get 4. Again if you are adding the what 4 to the 2 exactly 6. If you are adding the what 6 to the 2 exactly we are getting the what. If we are adding okay exactly 8. If you are adding the 8 plus 2 exactly 10 etc. These types of numbers. If you are adding the fixed number, these types of number it is known as AP sequence. Listen carefully. Let me give one more example. There is a 3, 7, 11, 15 and etc. Is it a sequence? Yes. Because see the common difference. Look at the board carefully. The common difference. If you are adding the 3 plus 4 exactly 7. 7 plus 4 exactly it is a 11. 11 plus 4 exactly it is a and etc. Let me give one more example. It is a AP. It is a what? AP. Here also it is a AP. AP is nothing but we need to add a fixed number. Yes. So here 1, 4, 9, 16 and 25 and etc. Is it an AP? Is it the difference is same? You don't take a 1 square is 1, 2 square is what? Here 1 square. Let me write like this: 1 square, 2 square, 3 square, 4 square and 5 square. Okay. We can't subtract the a square minus 1 square. We can't subtract the 3 square minus 2 square. No. So you just watch my previous video. It's the like terms and unlike terms. Okay, algebra videos. In this case, 4 minus 1, remaining is 3. So if you are adding the 1 with 3, we'll get 4. If you are adding the what 4 with what 5, exactly we'll get 9. See the common difference. That means the fixed number is different. Correct? The fixed number is different, isn't it? But it is not AP. The fixed number should be the same. Then only we can find the AP terms. Clear? Yes. So let me explain what is arithmetic progression general formula. The general formula. That means general form. So otherwise general formula. So general form is there is a plus d. First term is a, second term is a plus d, and a plus 2d, a plus 3d, and etc. plus a plus n minus 1 into the last term. Because here it's first term. The terms are denoted by either it is a t1, either a1 or small letter t1. Okay. So the second term is a2. Either is a A2 in examination, they can give the what? See, this is what the last term. Last term is AN. Either it is a TN. Either is a TN like this. Either we can define AN. Otherwise TN, small letter or big letter T. Okay. You can choose the any one. Okay. The nth term we are denoting like this. Otherwise we can also denote it with the last term as a N. So second term, and here it's a third term. Third term is A3. So, and the fourth term is A4. Look at the board carefully here. Look at the board. So here first term is just A. Second term is A plus D. First common is the A. And but 2 we get 1D. If it is 3 we are getting 2D. If it is 4 we are getting the 3D. Then how do you define the fourth term? Yes, the fourth term is A plus 3D. Simple. Clear? How do you define the fifth term? Fifth term is A plus 4D. Clear? And how do you define the 10th term? 10th term. This is what the terms. First term, second term, third term, fourth term, etc. Last term. How do you define the 10th term? A plus 9D. Clear? A plus 9D. If you take in 10, you just take a previous number. Yes. How do you define the what? A 100th term. 100. Yes, simple. A plus what? So that is a 99D. 99D. Clear? N, if it is, if you have defined n, the previous number is n minus 1. If you are taking 100 previous number is 99, right? 100 minus 1. So 100 minus 1 is 99. Similarly, n previous number n minus 1. A plus n minus 1 into d. This is what the nth formula. Okay? So you just copy the general formula. Again, we'll move on to the next concept. Okay. So here the nth term. Nth term of an AP is that so here an is equal to a plus n minus 1 into d. So in this case a is first term. A is what? First term, and d is called, what is a d? D is a common difference. We can also say it is a CD. CDR is nothing but it is a common difference. Okay. And how do you find the common difference? Common difference is defined as a d. D is equal to a2 minus a1. A2 minus a1 is nothing but if you are taking any number, we have to subtract with previous number. That means we have to take a second number minus first number, third number minus second number, fourth number minus third number, like this. So same, a3 minus a2, whatever it is. Okay, common difference. There is a one more formula, ap minus aq divided by p minus q. So there is a one more formula, ap minus aq divided by p minus q. Yes, our d is equal to a3 minus a2, otherwise a2 minus a1. We can follow the any one formula. And so sum of n terms, if they are given the sum, so we have to use this formula. There is a n by 2 into, there is a 2a plus n minus 1 into d. So 2a plus n minus 1 into d, n by 2 into 2a plus n minus 1 into d. It is the formula to finding the sum of n terms. Otherwise this one we can also written as n by 2 into a plus l. Otherwise r n by 2 into a plus an. Both are same. An is nothing but last term. Last term. Here the same thing in harmonic progression also. If it is the general formula here, first term is a, here the first term is a, second term is a plus d, third term is a plus 2d, etc. In the harmonic progression we are getting reciprocal, 1 by a and 1 by a plus d and 1 by a plus 2d, etc. Like it's a reciprocal. Then we can easily guess what is the nth term. What is the nth term? Nth term is 1 divided by a plus n minus 1 into d, like that. So if they are asking to any terms, you just take a reciprocal and find out the AP, and the final answer again reciprocal it and write down the answers. Okay, so this is what arithmetic progressions. This is what harmonic progression. So pause the video and note it down. I'll tell you the very important concepts of an arithmetic progression. Yes. Okay. In a sequence, if it is in an exact order, if it is in consecutive order, then how do you find that numbers? So for example, the sum of n natural numbers, as you know the sum formula, Sn is equal to, there is a n by 2 into, so 2a plus n minus 1 into d. Okay, this is what a sum. So sum formula, so sum is denoted by Sn. This is a sum. Okay, sum is nothing but addition. The adding all the numbers, this is sequence. Sequence is the sum of a sequence, it is nothing but series. Is it correct? Just we are adding. So sum of first natural numbers. Sum of first natural numbers. So for example, 1 plus 2 plus 3 plus 4 plus etc. plus, and it is 100. Then how do you find this sum? Taking a calculator and finding the plus 1 plus 2 plus 3 plus, no. We'll get a what? We don't have that much of time. Using the formula. So you just use this formula. There is a n into n plus 1. N plus 1 divided by 2. N is nothing but the last term. N into n plus 1 divided by 2. Clear? Yes. if it is the sum of first square natural numbers. Square natural numbers is nothing but 1 square, 2 square, 3 square plus 4 square and etc. plus 100 square. Whatever it is. Here I am taking a finite. The finite number is 100. If they are given the 200, we can substitute the n values of 200. Simple. If it is square, so just use this formula. Which formula? And very important, n into n plus 1 into 2n plus 1 divided by 6. Divided by 6. If they are in the cube, look at the word carefully, 1 cube. The sum of first cube natural numbers, 1 cube plus 2 cube plus 3 cube plus etc. plus 100 cube, etc. So many numbers are there, 3, 4 cube, 5 cube, etc. 99 cube and 100 cube. In this case, you just use n into n plus 1 divided by 2. Same, but write on the whole square here. Write on the whole square. Clear? Yes. If it is, look at the book carefully. If it is the sum of first, we need to take a first andre we have to take a first number 1, 2, 3. Don't take a starting number should be in the 1. If starting number start from 2, it won't works. The maximum question they'll ask from starting the starting number is 1 itself. Here, look at the board. Here, if it is the sum of first odd numbers, like 1 plus 3 plus and 5 plus etc. Okay, and here the 101. In this case, we need to do the square. So there is a n square. Simple. If you are doing the what? N square, we'll get to the sum. And the last one, if it is even number, the sum of first even natural numbers. Even natural numbers is what? 2 plus, 4 plus, 6 plus, etc. In this case, we need to use n into n plus 1. N into n plus 1. Note this, all the points and write down separately. And what? Practice well, definitely will crack all the what? CET questions in a AP and GP. The HP is also similar to the AP. Okay, so you just learn the AP. Next we'll move on to the GP. You just, before that, pause the video, note it down. Yes. So the next concept is a GP. GP is nothing but geometric progression. So we already discussed about the AP and HP. If you learn the AP, it is enough, not necessary to learn the HP. It is a reciprocal of AP. Okay, clear. The next completely different. It is not completely different. It is compared to the AP. It is different. GP, geometric progression. Look at the board carefully. I'll compare the AP and GP. So then only we can we'll get an idea. In the AP, A plus D, A plus 2D and etc. We are getting like this, the general form we are getting like this. But in the general form of GP is AR square, AR cube and etc. AR n minus 1. Here it is, we can find the D. D is nothing but what? It's a common difference. But in this case, R is nothing but it's a ratio. What? Ratio, difference. Here it's a difference, but it is a ratio. Here the first term is, this is what A is a first term. Here in that case also it is a first term. Here also first term. Is that correct? First term. Clear? And here nth term an is equal to a plus n minus 1 into d. Okay? Nth term is a plus n minus 1 into d. But in this case, nth term is denoted by an or tn or capital letter Tn. So there is a into r n minus 1. Note this formula carefully. And where a is a first term and r is the ratio. Then how do you find the ratio? In this case, say for example 2, 4, 6, 8, etc. So there is a common difference is 2. If you are adding the plus 2, exactly we are getting the next number. But in this case, look at the board carefully. Look at the board. 3, 6, 12, 24 and etc. In this case, the 6 second number divided by first number. Second number divided by first number, and that is equal to what? Next number, no? Just we are dividing numbers. If you are dividing these two numbers, the answer should be equal. That means the third number is 12, 12 divided by 6. Is it 3 ones are 3 twos are? Answer is 2, and that is equal to 6 ones are 6, 2s are. The answer is 2, and that is equal to the fourth number 24 divided by 12. 12 ones are 12 twos are. Answer is 12. If you are dividing the previous number 6 divided by 3, 12 divided by 6, 24 divided by 16. Just we have to divide. If you are dividing that number, if our answer is same, then only it is in the form of GP. Otherwise, it is not. Clear? In this case, we are adding. In this case, we are dividing. Clear? Then, what is the formula of R? R is equal to A2 divided by A1. A2 divided by A1. Otherwise, R is equal to A3 divided by A3 divided by A2. Okay, here is a ratio. A common difference is A2 minus A1. Clear? Yes. So, we will move on to the next sum.